Well, hello Internet, and welcome to part 3 of my Learning XML tutorial. Today I'm going to cover everything there is behind document type definitions. As I explained at the end of the last article, you create a document type to define the rules that must be followed in your XML markup. A DTD defines what elements are required and what attributes can be set and what their potential values can be. Every DTD must start with this line right here. This tells the processor that this is an XML version 1.0 file. The character encoding used is of type UTF-8, and that no external file is required for this document to work. And you can see that by looking at the attribute named standalone and the value that it is assigned to it being no. Also make sure when you are creating DTDs that element, @list, required, PC data, C data, etc. are all capitalized. In the DTD prologue, you describe your DTD in the following ways. With comments, you give a description of what the document contains. You start a comment with a bracket followed by an exclamation mark and 2 dashes, and end it with 2 dashes and another closing bracket. You tell the interpreter what version, encoding, and whether you require any outside files to operate with a statement like this. You tell the interpreter the location of any outside required files with the following statement that I have here. Note, if you don't require any outside files, standalone would have the value of yes. Also, you can refer to the location of a needed file like I did in the last example, only if it resides in the same file folder. You could also replace the file name customer data.dtd with a URL pointing at a DTD. Everything that lies between two tags on an HTML page is referred to as an element. So the paragraph tag that I have here, followed by the text that's going to go between that paragraph tag and the closing paragraph, is an element. You can use DTD to define a great deal of rules that must be followed for all elements on the page. Just to make myself clear, from the very beginning of the paragraph tag, including the text in between it, and the closing tag. Combined, that makes an element. Element is used to define what data can be placed in an element. It also defines how many times that data can be placed and in what order. Here's an example element definition. This statement is affecting data that is placed in the customer element. It demands that the data be entered in the same order they are listed. By not having an occurrence indicator defined, I'm stating that there can only be one customer ID. With the question mark occurrence operator, I'm stating that suffix can either be defined once or not at all. With the plus occurrence operator, I'm stating that there can be one or more products. With the multiplication occurrence operator, I'm stating that visits can be defined 0 or more times. Now I'm going to go over defining data in elements. The any definition allows the user to place any type of content in the element. And here is an example of how you would do that. With the child element definition, I allow the user to place only other elements in the element. And you don't define this rule with the word child element, but instead, like I show here in this example, where I list the names of those child elements in those brackets. Empty doesn't allow any information to be placed in an element, and you can also use an or statement. This allows either of multiple different types of data to be entered in an element. In the example, we're saying it's okay to add any type of character data with the PC data reference or child elements. PC data is known as parsed character data. This is character data that contains codes that the XML interpreter must decode. Parsed character data would contain the following codes that I show here in this example instead of the and sign, less than, or greater. C data, on the other hand, is just straight text that contains no character code. You define what attributes can be assigned to your elements with the @list name. You also use it to define the data type and any default values with it. The standard format is, as I show in this example, and a real-world example might look like this. Here I'm defining an attribute named first name. I'm assigning it to the customer element, and I'm saying that it has C data in it, and that it is going to be a requirement that this information be filled in. The first two elements used in the above attribute list definition are self-explanatory, so I'll define the data types available. C data accepts any character data that doesn't include the symbols and, quotes, less than, or greater than. You can use their escape versions, which are, as I show here. An identification number is generated to uniquely identify an element, much like you do with a database. A notation is a non-XML data that was specified with a notation declaration, and there'll be more on this in a second if you're a little confused. An entity is an alias to a previously defined block of text. Again, more on this in a minute. You also can use an enumerated list of values instead of a data type. An enumerated list is an all-inclusive list of every possible value. And here's an example. I'm creating an attribute named suffix for the element named customer, and then I am saying that the values it can contain would either be BA, MA, or PH. Finally, you define the default value for the attribute. All of the possible values for default value are required, which means exactly pretty much what it says. There must be a value. Fixed means the value is optional, but must be the value assigned if used. And here's an example of that. And this example states that if a customer is marked as new, they must be assigned the value of new. Implied means the attribute is totally optional. And value defines a specific default value. Here, much like the previous example, I'm using the element named customer, I'm assigning an attribute named new customer to it, and I'm saying if they want to use a value, it must be the text new. With an entity, you can declare a type of variable name that would represent a block of text, and here's an example of that, where I'm basically assigning this address to the word biz address. And I would be able to reference that later by just putting the and sign in front of it, and it would automatically throw the address directly into the XML. With this defined, I can now place an address anywhere by just using this code that I show here. This is known as an internal entity if it's defined in the DTD that is referencing it. An external entity is defined in an included file. You would define it with this sample format that I have here, in which I'm referencing a URL instead of content that is in the XML file itself. One of the great things about external entities is that they can reference images and other non-XML data. Just so I'm completely clear, you reference the entity by typing the and symbol followed by the entity name and then a semicolon. Also, you cannot make a call to an entity until you have already defined it in your code. External entities are either parsed or unparsed. Here, I'll explain that. Parsed data is either data that is of type text or XML. This data is interpreted by the XML parser. Unparsed, on the other hand, is data that is not of type text or XML. It can pretty much be any type of data. The XML parser will ignore this data because it doesn't understand it, and it will instead look for a helper tool that will be able to handle this data. Please note that unparsed external entities are defined differently so that they are passed on to the proper helper. You could define an image with code such as here. Here I'm referencing an entity named image name, and I'm defining the location of it, or the URL, and I'm saying it is of type JPEG. We define the name of the entity followed by the word system, then we include the URL address of the image, and data tells the parser that it needs outside help to work with this image, and JPEG is a notation, and I'll be covering that next. The notation element describes the format of non-XML data within an XML document. The basic format of a notation follows right here with this example, or for the image I was talking about above, here is how you would define that notation, where I'm creating the notation JPEG, and I'm telling the system that this is a JPEG with the image / JPEG definition here. In part 4 of my Learn XML tutorial, I will completely cover XML schemas. Till next time.